In this video, we will solve the initial value problem of this differential equation. And this is called the initial value problem, or the IVP, because the initial condition of the problem is given. So in this case, at x equals 0, the y value is negative ln 3. The first thing to notice about this differential equation is that it is separable. So recall that separable differential equations follows the form of, say we're dealing with dy over dx, the form follows a function in terms of x and another function in terms of y. So in this case, a function in terms of x will be this cosine x, and a function in terms of y will be this e to the 2y power. So the first step to solve a separable differential equation is to move all the terms of y to one side and all the terms in x to one side. So in this case, we have dy on the left, can multiply dx to the right, so it becomes this. And then we can divide these terms of y to the left side. So that'll become 1 over e to the 2y power dy cosine x dx. Then you simply take the integral of both sides. So on the left side, it will become the integral of 1 over e to 2y power dy in respect to y. And on the right side, it will be the integral of cosine x dx. So let's do the left side first. So the integral of the left side becomes, we can rewrite it. So it becomes e to the negative 2y. That's equivalent to this fraction, dy. And if we integrate it, it will become negative 1/2 e to the negative 2y. There's that plus c, and I'll denote it with plus c sub 1. And then let's solve the integral on the right side. So the integral of cosine x will become sine x. And then there's that plus c, I'll denote it as plus c sub 2. So if we equate these two, it becomes this new equation. Okay, now that we integrated both sides of the equation to get this big thing, I just simply brought it over here so I have more room to work with. So the next step to do is to solve for this y. Actually, before we solve for y, let's take a look at the constant c sub 1 and c sub 2. We know that they represent two values that could be the same value, or they could be different values. And if we were to do like the actual math, like combining the terms, so if we like subtract c sub 1 on both sides, we'll end up with this new equation. So negative 1/2 e to the negative 2y power is equal to, on the right side, it will be sine x plus c2 minus c1. That was a minus. So we end up with this c2 minus c1. And we could, because they represent like two constants, so we could just group them together and just call them a c, so plus c. And let's continue to solve for y. So next we'll divide negative 1/2 on both sides to get, so that will become negative 2 sine x minus 2c. And then if we take the natural log of both sides, so we can cancel out the exponent, we get negative 2y natural log of negative 2 sine x minus 2c, and then we simply divide ln negative 2 on both sides to solve for y. Okay, so the equation becomes the natural log or ln of negative 2 sine x minus 2c over negative 2. Now, we don't stop here because this is the general solution. So general solution. But we don't stop here because we were given the initial condition. So if we were given the initial condition, then that means we can solve for this constant c. So let's plug in the values. So like at x equals 0, y is equal to ln negative 3. So y is negative ln 3. That is equal to ln negative 2 sine x is equal to 0 minus 2c over negative 2. So you can see that c is the only variable. So only unknown variable, so we can solve for it. So we will solve for that by first multiplying negative 2 on both sides. We get 2 ln 3 on the left, on the right ln of negative 2. The sine of 0 is equal to 0, so this whole term is 0 minus negative 2c over, yeah. And then we can put exponent on both sides, so we end up with 3 squared because the ln and the e cancels out, so it becomes the functions can cancel each other out, so they becomes negative 2c. So now we can see that it'll be 9 over negative 2, and that is equal to our constant c. And then let's just rewrite the solution by substituting the variable c. So y becomes, so this here, so the function y becomes ln negative 2 sine x plus 9, because once you multiply negative 2 in the c constant, so here negative 2 times c, which is this, it becomes a positive 9, so that's where the plus 9 comes from, over negative 2. And that is our solution for this differential equation.